Okay. So let's start with linear search. So what is linear search? So linear search, the given element is to be compared with every element one by one, and once found, its location is uh, returned. Okay.
Okay.
So um, in this, what we are doing is up now. Suppose we have a we are creating a list. For example, um, let me initialize array again. So I'll initialize it over here. Um, this array we are initializing, and now what we are going to do is I am taking some random elements, so like 34, 65, 98, 1, 2, 4, 45, 87, 33, and 28. Like this, I am taking some random element over here. Right now, suppose we have to search an element, and we are taking search value. This search value is suppose 45. Okay, clear? So now what we have to do is we have to search this value in this array one by one. So what linear search process does is it compares starting from the zero index. So first of all, this will be compared with this, then not found this, not found this, not found this, and once it will come, it will be able to find this, and it will return the index of this value. Okay, now if we just return the index of this value, what it will be, this value will be just 4, while this location is 5. So what we have to do is whatever the index value plus 1 we have to give. Okay, so now we are applying the linear search. Okay, so in linear search what we have to do is first of all, we'll take we'll compare. So we can apply it using the while loop also. We can apply it using the for loop also. We'll see one by one how we can do. So indexing start will be will start at 0. Okay, while I is less than or equal to length of arr1. Okay, so length function, what length function is doing, length function is going to return the length of this. So you can just use it, test it like this, length of arr1. Okay, and I'll just comment this and I'll execute. So you can see it is printing length of this array is 8. There are 8 elements are there. Okay,
Yeah.
so I'll just comment it and activate this. So now, um, what we are going to do is we are going to compare if search underscore val is equal to arr1 of I. Okay, if this condition gets correct, then we have to print mm, the the search val, um, so we can say um number. This is available at position. We'll see position, and here we'll give it like this, and here we'll give in format. So I hope you remember this or output format.
Yeah.
Okay, so here we'll give search underscore val, comma, and here I'll give I plus 1. Now, why I'm giving I plus 1? Why I'm doing I plus 1?
Because index is from 0.
Index starts from 0. Correct.
Yeah.
Then here I am giving I plus is equal to 1. Okay, and then here I am doing this, and after coming over here, now what we have to do is we if let's suppose here I am executing this, so it is giving me that number 45 is available at position 5. Okay, this is the output it is giving. Okay, any doubt in this?
Okay.
Okay, it is giving. Now, if I want to make it more
No.
interactive in the sense, now let's suppose this number is at available here as well. So I'll execute. So it is telling me both time where it is available, right? So if there are multiple existence, it will give you multiple numbers as well. Okay. Now
Yeah.
I want to make it more interactive. Suppose I did not find this number at all. Okay, I am not able to find this number at all over here. So what we have to do? So we have to return a message also that the number was not available. Okay.
Yeah.
So let's suppose if I give a number like 48 I am giving, and if I am executing this, so it is not returning any output, right? Why it is not returning any output? Because this number is not available in the array. So it should give some message over here. So outside this loop, we can check if I is equal to length of array. Okay, and then we can print number search underscore val. Not this, not like this. Number does not exist. And here we can give in comma search underscore val. Now, if I try to execute like this, so what happened? Oh, equal to, double equal to. Okay. So now it is telling me that this number does not exist. Okay. Mm, here I have to give in format only. Format and search well like this. Then only it will work. Okay. So number, this does not exist. Is this correct? Is this understandable?
Yeah.
Now, do you find any issue with this code?
Give-
Just apply your logic and try to find, will this code work fine? You can say, sir, you have only told that this is, you have just shown that this is working fine. So what problem can come here?
Is
Can
it
you
that
try to,
if statement should be before the I plus is equal to 1?
this statement?
No, wait. Uh,
Hmm?
wait. I think this should work.
This will work, but there
Yeah.
will be one issue. Let me tell you what that issue will be. Now, suppose I am giving 87 over here. Okay.
Yeah.
So now when I'm executing this, you can see it is showing the position also, and at last it is telling that number 87 does not exist. Both condition in both case, if it does not
Oh,
exist, it is showing that it does not exist. But even if the number exists, first of all, it is showing the position of that number, and then it is telling that it does not exist.
yeah.
Is this contradictory?
Yeah.
So it should not behave like this. So for that, what we'll do? So simply, nothing big. Simply, we'll introduce a flag variable, and this flag variable will assign at 0. And here, as soon this is found, we'll do flag is equal to 1. And here instead of checking with I, we'll check with flag. If flag is equal to 0, then it will show this message, otherwise it will not show this message.
Okay, yeah, this works better.
Okay, so now if I execute 85, it is showing that 85 does not exist. When I am giving the 87, it will just give that this is available at this position.
Yeah,
Okay, fine.
yeah,
So this is what is your linear search. Okay, any doubt?
no,
Okay. Now, second thing in this comes is binary search. What is binary search? So, when we talk about the binary search is something like when like it means if we see some problem in linear search, so in linear search, what can happen? Suppose if there is a list of 10,000 elements, and in 10,000 elements, the item you are searching that may exist at 10th position, and it can exist at 990 position also. So, if it exists at a 990 position, it has to traverse through from first position to 989 position, right? So number of comparisons are too high, right? It has to
yeah,
compare a lot, right?
yeah,
So because of that, it may consume a large amount of time. It may consume a very big amount of time, right? And the purpose of data structure is to reduce the time complexity. Okay. So what is
yeah,
time complexity and how time complexity has to be calculated? We'll discuss that after a few sessions once we do some algorithms. After that, we'll discuss. But for now, you need to see the problem persisting with the linear search. So with linear search, problem is that there are too many comparisons involved with this, right? And because
yeah,
of this, the speed becomes very much slower. So to help over here, the binary search comes. Now what binary search is doing, so in binary search, first of all, data is arranged in sorted order. Okay, data is
okay,
arranged in sorted order. Okay, now the binary search will not start, it will not start comparison from beginning. Okay, it will not start from zero index or one index like that, first position. It will not start. It will, what it will do is, first of all, it will divide the entire array into two parts. Okay.
yeah,
First of all, so I'm telling you means one by one, step by step, how we are going to do. First of all, it will be entire. So to do this, find the middle value. Okay, it
yeah,
will find what is the middle value. Means once it is sorted, it will find the middle value. Now, what it will do is it will perform comparison comparison uh, of search element with middle value. Okay, so what this will do is it will perform it. First of all, it will find the middle value in the sorted, and once it compares the value that are in sorted order, and middle value is being performed. Now, if now for example, let me open Excel. Um, okay, let me reshare my screen. Okay, so now, for example, we have a sorted list like 11, 22, 33, 44, 55, 66, 77, 88, 99. Right? Now
Yeah.
we have this list in sorted order. Now what binary search is doing, first of all, it is finding the middle element. So since there are nine numbers, so middle element will be this. Okay, this is middle element. If there are even numbers, so what it will do is, suppose if numbers are like this, on only till this place it is there, so it will find these two values and it will find the average of these two values, and that value will be considered as the middle value. Okay,
Yeah.
so now it will perform the comparison with middle value. So here 55 is middle value, and your search value is, suppose you have to search 62. Okay, suppose you have to search 62. Now when it will compare this with this 62 with 55, so what will happen? It will find that 62 is greater than 55, right? So now it is clear that 62 cannot exist before this,
Yeah.
right?
Yeah. Yeah.
Understood?
Yes.
62 can now only exist between this part. Okay?
Okay.
Now, when so you can see how drastically with just one comparison only, it has rejected half of the list.
Okay.
Understood?
Yeah.
Now, in the second list, now this is our list, right? In these two are middle numbers.
Okay.
Okay. Now it will take the average of these two numbers. So average of these two numbers is 82.5. Now the 62 will be compared with this 82.5, right? So
Yeah.
now it is clear that it will not exist in this part. It will exist in this part.
Yeah.
Like that, it will perform the segmentation by comparison
Okay.
of the middle value. So every time it will compare the middle value. Okay,
Yeah.
understood the process what binary search is doing?
Yeah.
Great. So let me share the Python screen now. Okay. So now let me write. So if middle value is less than search value, it it will reject half part of list and perform search in in the remaining part. Okay, so
Yeah.
you can understand in your own way. So now let us see how we can write the code for this. Okay.
Yeah.
So we'll define binary search function over here. We'll do it by function. Okay. So define define binary b search. We are taking b search. Okay. And here what we are doing is, first of all, we are passing the array over here. So suppose we have created the array, and then the search value we are taking over here. Okay. Here now how we have to apply. So let's suppose we have an element. So initially we have to we have two places. One is the index 0, and another one is index 1. So before that, before applying this binary search, we have to make sure that the array that we are passing is in sorted order. Okay.
Okay.
So we'll do sorting before this function itself, and this function I am making, assuming that my array is already in sorted order. Okay. So now I am taking, first of all, left is equal to 0, because at the initial, it will start from 0 index, and right is equal to length of array minus 1. Right?
Yeah.
Understood, bhai? I am starting from length of array minus 1.
Yeah.
Okay. So because at initial, we are starting from very start of the array and going till last. Okay. Now what we have to do is we have to find the middle value. So to find the middle value, what we have to do is mid is equal to um, left plus right divided by 2. Okay.
Yeah.
Are you just we are getting taking so we are going to do the floor division over here. Okay, we are not going to take any those means the decimal part of it. So we are doing just floor division. So for that we have taken double slash. Okay. Now what I am doing is, so this is not final. Still, one loop will be applied. I am just taking it at initial. So what we are going to do is, um, now if ARR of mid is greater than search underscore val. Okay.
Yeah.
So let me write an algorithm, then I'll explain it again. Okay.
Okay.
Um, I will say if ARR mid is equal to search val, that means we have to return what return mid position, uh, else if this is if they are not equal, then what we have to do, we have to check again if ARR mid is less than, if ARR mid is less than the search value, then now when this mid value is less than search value, means array will exist in the right part.
Yeah.
Understood. So for example, if we have let's say 11, 22, 33, 44, 55, 66, 77, 88, 99, we have the value, right? So when this is the middle value and our search value is suppose 62. Okay, so if now this value is less than this value, so what will happen? Your starting of array will move from this position to this position.
Okay.
Correct? Are you
Yeah.
able to follow with me?
Yeah. Yeah.
Okay, see, this is a little conceptual part, so you have to be with me. If you do not understand, just let me know.
No, I
Okay.
understand. Yeah.
So initially our left was starting from this position. Now right will be as it is, because now when comparison, first comparison is done, this comparison is now this is bigger. So 62 has possibility, and so 62 has no possibility to reside at this. It has possibility to be at this place in this array. So now we'll start from this. So our left will be at this position and right will be as it is. Okay, so what we'll do is left is equal to mid plus 1. Okay, so this was our mid position plus one position is this. Now we'll start from this. Okay,
Yeah.
if this is also not there, this means this means it is not equal also, it is not less also, it must be greater than. Then we can, then we have to shift. Means if suppose value is value is 40. Okay, so it has the possibility to reside at this place, so the right part will come at this and left will be as it is. Okay,
Yeah.
so this will be right is equal to mid minus 1. Okay, clear है ये?
Yeah.
ओके, ग्रेट। अगर इतना क्लियर है, अभी अभी अब इसमें हमें क्या करना है कि अगर ये पूरी प्रोसेस हमें एग्जीक्यूट करानी है, लेकिन ये हमें तब तक कंटिन्यू कराना है जब तक कि हमें अपना या तो एलिमेंट नहीं मिल जाता, तब तक हम इसको कंटिन्यू कराएंगे। तो इसके लिए हम कंडीशन क्या लगाएंगे? तो इसमें हमारी टर्मिनेशन कंडीशन क्या होगी कि जब तक हमारा while लेफ्ट इज लेस देन राइट, जब तक हमारा लेफ्ट राइट से कम है तभी तक हम इसको चला सकते हैं। अगर हमारा लेफ्ट राइट से ज्यादा हो गया, इसका मतलब हम सारी पॉसिबिलिटीज को सर्च कर चुके हैं, अब इसके एग्जिस्टेंस की कोई भी पॉसिबिलिटी नहीं है।
Yeah.
अंडरस्टूड?
हाँ
अंडरस्टूड भाई, वी अप्लाइड दिस लेफ्ट इज लेफ्ट लेस देन राइट।
हाँ हाँ हाँ।
ओके,
मैक्सिमम इंडेक्स क्रॉस हो गया तो खत्म हो गया।
हाँ, अगर हमारी जो पॉसिबिलिटी है वो क्रॉस हो गई तो फिर बचने की कोई पॉसिबिलिटी नहीं है। तो यहाँ पे फिर हम उसको हम टर्मिनेट कर देंगे। तो अब टर्मिनेशन के लिए हमने यहाँ पे कंडीशन लगाई है, और ऐसी कंडीशन में एक तो एक यहाँ पे हमारा रिटर्न ये जा रहा है, ठीक है। तो अगर उसको मिल गया तो ये रिटर्न कर देगा, पूरा फंक्शन क्लोज हो जाएगा। अगर नहीं मिलता है तो हमने सिंपली दे दिया रिटर्न -1, ठीक है। अब इसके बाद हम यहाँ पे एरे दे देते हैं। सपोज यहाँ पे हमने दिया माई ए आर आर इज इक्वल टू, अभी मैं इसको सॉर्टेड फॉर्म में ही दे देता हूँ, ठीक है। माई माई लिस्ट बना लेते हैं पहले हम। माई ए आर आर ही कर लेते हैं। माई ए आर आर इज इक्वल टू इस कॉपी कर लेते हैं, एंड यहाँ पे हम दे देते हैं 11 22 33 44 55 60 77 88 99। ओके, और यहाँ पे सर्च वेल, यहाँ पे हम दे देते हैं टारगेट वेर इज इक्वल टू, सपोज आई एम गिविंग 77। ओके, एंड फिर यहाँ पे अब मैं इस बाइनरी सर्च फंक्शन को कॉल कर लेता हूँ। सो बी सर्च, एंड हियर आई एम पासिंग फर्स्ट ऑफ ऑल माई ए आर आर कॉमा टारगेट अंडरस्कोर वेर। सो हमने यहाँ पे इसको पास कर दिया, और इसके बाद फिर हम यहाँ पे पॉसिबिलिटी सर्च करते हैं। तो ये यहाँ पे एग्जीक्यूट हो जाएगा, और एग्जीक्यूट होके इसकी जो वैल्यू है वो हम एक जगह पे स्टोर करा लेंगे। उसको हम रिजल्ट में स्टोर करा लेते हैं। तो यहाँ पे हमने दिया रिजल्ट, और अब यहाँ पे हम सर्च करें, इफ कंपेयर करेंगे, इफ रिजल्ट इज इक्वल टू -1, देन प्रिंट नंबर डू नंबर do not exist. Okay, and
Yeah.
else print location of num number is और यहाँ पे हमने दे दिया कॉमा रिजल्ट। ओके,
Yeah.
ठीक है। अब हम इसको रन कराते हैं, लेट्स सी ये वर्क करेगा या नहीं। सो सी इसने दिखा दिया कि ये सिक्स पोजीशन पे यहाँ पे एग्जिस्ट कर रहा है। ठीक है, अभी
ओके।
यहाँ पे ये सिक्स क्या दिखा रहा है यहाँ पे? अभी यहाँ पे आप देखो तो ये सेवेंथ नंबर पे एग्जिस्ट कर रहा है, लेकिन सिक्स यहाँ पे क्या आ रहा है?
इंडेक्स।
इंडेक्स आ रहा है, राइट।
हाँ।
सो हमने यहाँ पे इसको +1 कर दिया।
ओके।
ओके, सो इसने हमें एग्जैक्ट दिखा दिया कि यहाँ पे ये नंबर कहाँ पे एग्जिस्ट कर रहा है। ठीक है, तो यहाँ पे हम नंबर, यहाँ पे हम वैल्यू भी दे सकते हैं, तो यहाँ पे हमने इस तरह से इसको दे दिया और यहाँ पे इसको दे दिया, और यहाँ पे हम फॉर्मेट डाल देते हैं, डॉट फॉर्मेट, और टारगेट टारगेट अंडरस्कोर वेर कॉमा रिजल्ट। ओके, दिस इज हाउ वी कैन इम्प्लीमेंट दिस एंटायर। एंड नाउ अब हम यहाँ पे एक ऐसा नंबर डाल देते हैं जो कि एग्जिस्ट नहीं करता है, राइट। तो यहाँ पे हमने इसको एग्जीक्यूट कराया, तो इसने दिखा दिया नंबर डू नॉट एग्जिस्ट। ठीक है,
ओके।
क्लियर। अभी हमने
या।
यहाँ पे 33 डाल दिया, और इसको हमने यहाँ पे एग्जिस्ट। ठीक
ठीक।
है,
हाँ।
क्लियर।
एंड इसकी टाइम कॉम्प्लेक्सिटी कैसे पता चलती है?
टाइम कॉम्प्लेक्सिटी में थोड़े एक दो तीन एल्गोरिदम्स और हो जाए, फिर मैं आपको बताता हूँ टाइम कॉम्प्लेक्सिटी कैसे कैलकुलेट होगी। ठीक है,
ओके।
तो उसमें आपको पता लग जाएगा कि कैसे चीजें यहाँ पे वर्क करती हैं।
ओके।
ठीक है, इसमें टफ तो नहीं लग रहा, समझ में आ रहा है आसानी
नहीं,
से?
आसान है ये तो। हाँ।
पहले किया हुआ आपने?
हाँ।
हम्म,
हाँ।
ये पहले कहाँ किया हुआ? अच्छा, ये C++ में किया होगा आपने।
हाँ। हाँ। हाँ।
पाइथन में पहली बार इम्प्लीमेंट किया है?
हाँ।
ओके, ग्रेट। अब इसके बाद आप यहाँ पे कोई भी लिस्ट चीज ले सकते हो। अब यहाँ पे बेसिकली अगर यहाँ पे सॉर्टेड लिस्ट नहीं है, तो सॉर्टेड लिस्ट में आपको यहाँ पे पहले सॉर्ट कराना पड़ेगा, और सॉर्ट करा के आप यहाँ पे नंबर अपने अकॉर्डिंग दे सकते हो। ठीक है, सो वी हैव नाउ कवर्ड द सर्चिंग पार्ट, लीनियर सर्च एंड बाइनरी सर्च बोथ. Now we are going to cover the different types of sorting. So we have selection sort, we have bubble sort. So we'll try to cover one by one. Okay. So now next is we are going to see the selection sort. So in selection sort, have you studied selection sort earlier? Have you seen?
नो।
Okay. So let me tell you how selection sort works. Uh, so suppose you have the number. First of all, I'll explain the process, then I'll write the step one by one. So suppose you have the numbers like 34, then 23, 89, 65, 77, and 12. Okay, you have these six numbers. Okay, now what selection sort is doing is, selection sort selects one number from top and compares that number with all other numbers. Okay, so here what it will do is, um, first of all, this is first iteration. Okay, first iteration. In this, what it is doing is, it is selecting this 34 from here, and it is comparing this 34 with this number. Okay, so whatever number will be there at first position, it will compare that with others, right? Now, since we are arranging this in ascending order, so uh, suppose it has found this 34, it is greater than 23. So what it will do, wherever it will find the smaller number, it will perform a swap. Okay, so in this, here it will be 34 and 23, and 34 will come here. Rest list will be as it is. Okay. Now in next, now it will compare 23 with 89. 23 is smaller, no change. 23 with 65, smaller, no change. 23 with 77, 23 is smaller, no change. Now 23 is compared with 12. Again, 12 is smaller than 23, so it will perform swap with this. So 12 will come here, rest all will be as it is, and 23 will come here. Okay, so it has compared from this to this, all numbers has been compared. And after, so now first iteration is completed. After first iteration, the smallest number in list is at top. Okay,
Yeah.
so now in second iteration, it will start. Now second iteration will start not from top. It will start from second position. Okay. Now 34 will be compared with 89. No change. 34 will be compared with 65. No change. 34 will be compared with 77. No change. 34 will be compared with 23. So this 12 was as it is. 23 will come here. 34 will come here. And rest will be as it is. 89, 65, and 77. So by now, second iteration is completed. And now the second smallest is at second top. Okay. Are
Okay.
you getting this process?
Yeah.
Okay. In the same way, it will go to third, no, means it will start positioning from here. So now in
Are
third
you
iteration,
typing something or just saying because the
sorry,
screen, are you typing something right now?
yes, the screen is not
Oh,
visible.
no, screen is frozen, I think. I can just see selection sort written.
Just
That,
a minute.
yeah, nothing else.
Why it is happening? Is it visible now?
Yeah, yeah, yeah. Okay.
Okay. So here, should I explain again?
Yeah,
Okay. So now what it is doing is it is starting from this 34. Comparison is starting from 34. 34 will be compared with all other elements, right?
okay.
And since we are sorting in ascending order, so if it finds a smaller element, it will perform a swap. Okay. So first of all, it has compared 34 with this 23. 23 is smaller. So swap is performed. 23 is over here and 34 is over here. And rest are as it is. Okay.
Yeah,
Now, this 23 will be compared with this. So, whatever the element at top position will be compared with all other element. Now, 23 will be compared with this, no change. 23 compared with 65, no change. 23 compared with 77, no change. 23 compared with 12. Now, 12 is smaller, right?
yeah, yeah.
So, it will perform again swap. So, 12 will be here, 23 is here, and the rest will be as it is. So by this first iteration is completed, and after completion of this first iteration, the smallest number is at top position.
Okay.
Okay. Now the second iteration will come. In second iteration, now it will start from this. Start from second index. Okay. So second index is this, right?
Yeah,
So now this will be compared with all other elements. So 34 compared with 89, no change. 34 compared with 65, no change. 34 compared with 77, no change. 34 compared with 23. 23 is smaller, it will perform a change. 23 has come here, and 34 has come here. Iteration is over. Now you can see smallest is at second top.
Okay.
Understood?
Yeah.
Now third iteration. So in third iteration, it will start from third index. So third index is 2. It will start comparison from this, right?
Yeah.
So 12 and 20, 12 and 23 are as it is. It is comparing 89 with 34. 34 has come here, 89 has come here. Okay, rest these two are as it is. Now this 34 will be compared with this, 34 will be compared with this, and 34 will be compared with this. No change. You can see third smallest is at third top.
Yeah.
Okay. So, like this process will continue till last.
Okay.
By the way, this is already sorted at third index itself because
Yeah.
list is like this. It is already sorted at third index itself, but it will perform entire process by itself.
Okay.
Understood?
Yeah.
Understood the process of selection sort?
Yeah.
Any doubt in this? Any doubt in this?
Can we go scroll up to the first iteration once?
Hmm.
So first we were comparing 30, uh,
34 with 23.
yeah. So the 23 is less. So then
Hmm.
23 became the smallest on top.
Hmm.
Then, okay.
Okay.
One second. So, okay. So the first iteration is to find the smallest number in the whole sequence. Okay.
Yes. Yes.
Okay.
First iteration will find the smallest in whole sequence. Then second iteration, second is smallest. Third iteration, third is smallest. Like this, it will work.
Okay.
Clear?
Yeah.
So we'll code this now. The coding may take time. So can we discuss this coding tomorrow?
Yeah.
Because I have another class from 4, and we won't be able to cover this in just 5 minutes. I'll share this code with you as soon it will the code will be is already ready. After the class I'll send you. Okay.
Okay.
Okay, thanks.
Thank you, sir.
Thank you.